Hey, to round out chapter 15, we're going to take a look at how to make a copy of a class or an object that doesn't refer to the object that you're copying. So to make this clear, I'm going to import a module called copy that does the copying for us. Create a new class called point. It's one of the, again, the simplest class that you can make where we don't do much inside of point. I'm going to instantiate point or create an instance of point called P1, and I'm going to set P2 equal to P1. And then I'm going to add some attributes to P1. So I'm going to create P1.x and P1.y. And again, Python looks at P1.x and says, let's go up here to class point. Do I see anything about x's up here? No, I'm going to then create a new name P1.x, and we're going to go ahead and set that equal to 0. And P1.y equal to 1. And then I'm going to print off P2.x and P2.y. Not P1, which I've just declared, but P2. And then I'm going to change P2.x and P2.y to be negative 3 and 4 and print off P1. And what we're going to find out is that P2 and P1 are just aliases for the same pieces of memory. So if I make a change to one of these, I make a change to the other. And that is the effect of copying a class this way. So after we do that, I'm going to use the copy module to create a copy of P1 using the copy.copy command. So notice that we have this dot notation. That means that copy is actually a class. And what we're going to find out then is if we print P3.x and P3.y, because we've copied P1, it's going to have the values of P1. But then if we change P3 and we change P1, when we come down here and print off P1, P2, and P3, we'll find that P1 and P2 again are the same. They point to this, they're looking at the same piece of memory, but P3 on the other hand is going to be looking at something new. So P3 will be unaffected by these changes to P1. So when we do a copy like this, it copies over the format for P1, and initially P3 will have the same values as P1, but it's looking at a different piece of memory. So it gives us a new area to store our variables in. And we'll see when we print out the IDs the difference between creating an alias like P2 and creating a copy like P3. Okay, so again, set P1.x to 0, P1.y to 1, and if I print off P2 and P1, we get that 0, 1. Then we change P2 and P3, but we print off P1, and we get the negative 3, 4. So changing P2 has changed P1. Create a copy of P3 and print off P3, and because P1 is now equal to negative 3, 4, that's what we get for P3. But then we make the change so that P3, the point P3 is 4, 2, whereas the point P1 we're setting to 5 minus 3, and we find out that that change to P1 again makes a change to P2, but P3 remains the 4, 2 that we declared up here. And if we look at the IDs for P1 and P2, they're the same. If we look at the ID for P3, it's actually different. Okay, so one last thing we want to look at is the idea that objects are mutable. So they behave in some ways like lists and dictionaries. And I'm going to declare a class stays the same. And again, the simplest class we can make. We are going to actually have classes that do some things, but maybe not just yet. And I'm going to instantiate that as an instance 1, print the ID for instance 1. And I'm going to declare instance.x to be 0, and I'm going to declare a new integer x to be 0. And there's going to be a little surprise here. So you shouldn't think of these two things as being the same x. This is an attribute inside of a class, and this is an integer. So the reality is you really should think of these as being two different things, but Python does something clever here, and it tries to save memory, and it says, oh, well, if you got two integers and they're both 0, I'm actually going to use them in the same spot. So when we print out the ID for instance 1, instance1.x and ID x, we're going to find out a little surprise that these two are actually going to have the same ID. But then what we're going to do is we're going to make a change to instance1.x. We're going to add 1 to it, and we're going to add 2 to x, and print out the IDs again, and we'll see, again, something interesting. I think it's interesting. So we run this, and so the ID for instance 1 is here. Then we give a new attribute to instance 1, x, and we set it equal to 0. We'll create a new integer, x, also 0. And it turns out those have the same ID. So again, Python's just being clever. You really hadn't ought to think of these two things as being the same thing just because they both use the variable x. That's not really the way it works. So we come down here and we add 1 to instance1.x, and we add 2 to x. Again, we're using the dot notation. X is an attribute for this object. And when we print out the IDs, now we find out, so this is where I'm talking about the fact that instance 1 is mutable as an object. So the ID for instance1.x has changed, and so is the ID for x. But what hasn't changed is the ID for instance 1. And remember that instance 1 actually contains that variable x in a way. So we may have changed the instance1.x, but the class, or the object itself, instance 1, hasn't changed. So again, objects are mutable types. You can make changes to the object, but the object is still going to be in the same spot. So just to emphasize here that we really shouldn't think of instance1.x and x to be the same. I wish I'd thought of this earlier. I'm going to change this to y. So every time where I have just an x, I'm going to make it a y. Sometimes Python's too clever for my own good. Let's see, stays the same. Oh, whoops, that's not what I wanted to do. That's still x. This is y. Okay, maybe that'll do it. Yeah, there we go. So notice that because instance1.x and y are both integers in the same integer, Python is conserving space by giving them the same ID, or having them point to the same piece of memory. But down here, when we add the 1 and we add the 2, now they are pointing to different pieces of memory. And I changed this to y just again to emphasize the fact that you really shouldn't think of these two as being the same thing. They're really quite different. This belongs to an object. This doesn't, even though Python in some ways is treating them the same. Okay, anyways, the goal of this point, or the goal of this little program, was to show you that objects are mutable. So any changes we've made has not changed the ID for that instance 1. And there we go.